Alright, welcome back guys. We're going to go over this final video, which is the review for the final exam. So, I'll go ahead and get started. And guys, I'm going to show you, similar to the way I've done the previous reviews, I'll just show you probably the most efficient or fastest method to come to the correct solutions on these. Okay, even though we may have talked about more complex methods or more mathematical methods in class. So anyway, this first one starts with graphing, and I would just graph it in my calculator. Okay, but guys, if you remember anything about those transformations, this is a quadratic function. It's got a negative in front of it, so it's going to be an upside down parabola. And it's got a -7 out here to the side. So it's going to be an upside down parabola shifted down 7 units. So it's got to be choice D. Okay. So some of these you may be able to do without graphing, if you can remember some of those transformations. Alright, number 2, it says this function f, it's f of c, gives the Fahrenheit temperature corresponding to the Celsius temperature. Okay, so all this function does is convert a temperature measurement in Celsius to that of Fahrenheit. And so it says find the Fahrenheit temperature equivalent to 25 degrees Celsius. Well, that just means plug 25 into this function. Okay, so in other words, we want to find f of 25. So this will give me 9/5 times 25 plus 32. And here, I'm going to take a shortcut. 25 divided by 5 is 5. And I'll multiply this 5 to the 9, and that's 45. Plus 32 will be 77. Okay? And you can double check this in your calculator as well. So 77 degrees Fahrenheit. You know, in the U.S., we're not very accustomed to or familiar with temperature measurements in Celsius. But if you go to virtually anywhere else in the world, they are. Okay, number 3, determine if the graph is a function. Well, this would not pass the vertical line test, guys, so this is not the graph of a function. Okay, or in other words, there would be like 2 points, say for example here and here. Both of these ordered pairs have x coordinates of -2, but they have 2 different y coordinates. Okay, so that would be an example of one element in the domain going to 2 different elements in the range. Alright, example 4. Okay, with example 4, I could work this out the way I showed you in class. Okay, using the elimination method. Or guys, I can simply do this using matrices. So I'm going to kind of refresh you on that. So with matrices, we had 2 matrices. We called them A and B. And A was our coefficient matrix. In other words, it represented all the coefficients for the variables. Okay. So if I write those coefficients as a matrix, I'll have 1, 1, 1, okay, for 1x, 1y, and 1z. And I'll have 1, -1, and 2. And then for my third row, I'll have 5, 1, and 1. Okay, so this is my matrix A. And then my constant matrix B is going to be a 3 by 1 matrix, just consisting of those constants. Okay, so matrix A is a 3 by 3, matrix B is a 3 by 1. If you guys remember that about matrices. And to actually use matrices to solve this system, you need to tell the calculator to do this. Take the inverse of matrix A and multiply it to matrix B. Okay, so how do we do this in the calculator? So I'm going to refresh you here. you're going to go to the matrix key. Okay, so you got to hit second, and then this X inverse key, and then you just hit number 1. Just hit enter. Whoops, no, actually, you don't do that. I've got to edit matrix A. So go back. Let's go back to the matrix key. And let's come over here to edit. Now I'm going to hit enter. And make sure you got the right dimension. Okay, matrix A is a 3 by 3. You can see I've got the information from that last example that we did toward the beginning of the semester. Now I'm going to input my entries. Remember, you've got to be careful here, because if you get one entry incorrect, it'll throw off the solution. Alright. Now, you can still solve these by hand if that's what you would like to do. Alright, so I've got matrix A in there, so I'm going to go back to the matrix key. I'm going to go over to edit again. I'm going to go down to number 2 because I need to input the entries from matrix B. And matrix B is a 3 by 1. Remember, it's the number of rows by columns. And so our entries are 7, 7, and 11. Okay. Now what I do is I quit this screen. So I go to second mode. And now I need to type into the calculator what I've got right here. So I'm going to go back to the matrix key. But I don't go to edit. I just select matrix A. And I hit this key to take the inverse of it. And then you can say times if you want or not. It doesn't matter because the calculator will understand. And then go get matrix B. Scroll down to number 2. And we've got it in here. So now when we hit enter, it'll give us another 3 by 1 matrix that contains the solutions. Okay, so we end up getting this matrix 1, 2, and 4. So these correspond to X, Y, and Z. Okay, so it's an ordered triple. It's got to be choice A. Okay. Alright, so we'll continue. Number 5 here, it says, for the function represented in the graph, find its domain. Okay, so, well, this function starts down here, and the x-coordinate, remember the domain refers to the x values, the inputs of the function. So it starts down here. That x-coordinate is -1, so that's where it starts. It stops up here, and that x-coordinate is 4. So the domain is from -1 to 4, but it's inclusive because these points are filled in. So that means -1 and +4 are included. Okay, so it's got to be choice B. Oops. Alright, number 6. This says match the inequality with a graph. So the way we did these was we treated the inequality as if it were an equation. And we graphed a line, and we looked at the inequality symbol to determine whether it was a dashed line or a solid line. Or in other words, to determine whether the points on the line were included or excluded. Okay? So the first thing I need to do is put it in slope-intercept form. Let me zoom in a bit so I've got plenty of room. I'll do that over here. So 2x plus 5y is strictly greater than -4. Alright, so I'm going to go ahead and subtract 2x from both sides. If I do that, that'll leave me with 5y is greater than -2x minus 4. And I'm going to divide both sides by 5. Okay, so this will give me y is greater than -2/5 x minus 4/5. Alright, so remember, your y-intercept is right here at -4/5, and m represents your slope. So guys, negative 4/5 is the same as negative 0.8. So this is going to cross the y-axis close to negative 1. So it cannot be C. I don't think it can be B, nor do I think it can be A, just by looking. And notice, I can't actually zoom in on any of these, but you guys will be able to. Well, wait a minute. No, I'm wrong on this, I think, because these are in increments of 2 and not 1. See? So because of that, it cannot be D, because here it crosses at negative 2. It cannot be C, because it's crossing a little bit above the x-axis here. So it's either A or B. Now, A or B virtually have the same line. One's dashed and one's solid. Well, because this is a strict inequality symbol and it says greater than, it's got to be a dashed line, and we're shading above the line. Okay, so it's got to be B. So in other words, this region here that's shaded, this contains all of the ordered pairs that would make this original inequality a true statement. Remember, these inequalities, they have infinitely many solutions. Sometimes they include the points on the line and sometimes they don't, depending on the nature of the inequality. All right. Number 7. Okay, I think I even told you guys in class that the ladder problem, as it was known, is even on the final. Okay, so let's go ahead and do this one. It says, so a ladder is resting against a wall. The top of the ladder touches the wall at a height of 12 feet. So remember, guys, we're using the Pythagorean theorem here. You're going to get a right triangle. Okay, so this side is 12 feet. I'm just going to put 12. The ladder is the hypotenuse. And it says, find the length of the ladder. Find the length of the ladder if the length is 4 more than its distance from the wall. Okay? So we need to let x represent something that we don't know. I always like to let it represent the shorter side. So the length of the ladder is 4 more feet than its distance from the wall. So the distance from the wall is actually the shorter distance. So I'll let x represent the distance from the wall. So that's this distance right here. I'll just call that the ground. Okay. And so that would make the distance of the ladder, the length of the ladder, x plus 4. Okay. And so that the Pythagorean theorem is a squared plus b squared equals c squared. And A and B represent the legs, and C represents the hypotenuse. So, my legs are 12 and x, and the hypotenuse is x plus 4. So if I plug these in, I'll have 12 squared plus x squared equals that hypotenuse, which is a binomial squared. Okay. Now, guys, to square this stuff, well, 12 squared is 144. X squared is just x squared. But to square this binomial, you have to use the FOIL method. You guys remember that? These are just rhetorical questions at this point. All right, so, you know, if you do all this, guys, you're going to end up getting x squared. You get a 4x and a 4x, which would be 8x if you combine those, and then you would get a 16. Okay, so that's what I'm going to plug in over here. Right. And now what we do is we solve this equation for x. Now this looks like it's a quadratic equation, but it's not. Because if I try to go ahead and start moving everything to one side, my x squareds would cancel. In fact, I'll go ahead and do that. Okay, so they end up disappearing, so we end up with just a linear equation. Okay, so we solve this for x. I'm going to subtract 16 both sides. This will leave me with 8x is equal to, oh, what's that? I think it's going to be 128. And if I divide both sides by 8, I'm going to get that x is equal to I should know this. 16, okay? And guys, x is actually what we're looking for. The question is, or no, it's not either. That's why you got to be careful here. See, it's not, x represents this distance right here. The question is, what's the distance or the length of the ladder? Well, it's 16 plus 4, so it's actually 20 feet long. Okay, so be careful on that one. Alright, my cat is literally right in front of the laptop, biting on the backpack. Okay, number 8, it says find the domain and then write in interval notation. Well, guys, you've got to remember the domain comes from the denominator, okay? We don't want that denominator to ever become 0. So to figure out what the domain is, or what's not in the domain, we take that denominator, we set it equal to 0, and we solve it for x. Well, looking at this guy, this is a quadratic equation. It's in standard form, so you can use the quadratic formula if you want. Or this one can be factored. I could factor it by taking an x out, and that would leave me with an x plus 2. And then if I set each of these factors equal to 0, this one I'd have to subtract 2 from both sides, then I'd get 0 and negative 2. So these are the two numbers that are not in the domain. So that means the domain in interval notation is going to go from negative infinity all the way to the lower of these two, which would be negative 2. And then from negative 2 to 0, all the numbers in between. And then finally from 0 all the way to positive infinity. So this to me looks like it's got to be A. You definitely know it's not B or D, okay? One way you could figure this out, guys, kind of backwards, is you can see in both of these examples there's exclusions of negative 2 and negative 2, 0, and 1. So you can plug those numbers in here and see which one makes that denominator 0. And you could figure it out that way. If you plug 1 in, the denominator will not become 0. Okay, so that means that 1 is actually in the domain, not excluded from the domain. Okay, so number 9, this is one of your favorites. We have to construct and simplify the difference quotient. Okay, so what we do here, guys, is the first thing we do is we plug x plus h into this function. So if I do that, I'll have 9 times x plus h squared plus 9 times x plus h. And then you got to say minus, okay, up here, and then you plug in f of x. Well, f of x is this function, and if it has more than one term, you need to keep it in parentheses, because that negative ends up having to get distributed, okay? And then technically this is all over h, but I don't like to put that in there until the very end. Okay, so now we've got some expanding to do. So the first thing we need to do is expand this x plus h squared. So you got to remember that you're multiplying two binomials again, okay? So I'm going to do this real quick, guys. If you do all this, you're going to get x squared plus 2xh plus h squared. And then you multiply everything by the 9. So I'm going to go ahead and do that. So I would end up getting 9x squared plus 18xh plus 9h squared. Okay, so I did a lot real quickly. And then I would distribute the 9 here. So that would give me a 9x plus a 9h, and then I'll distribute this last negative. That would give me a negative 9x squared and a negative 9x. Now this is the part where you should be able to combine and cancel a lot of these terms. So the 9x squareds cancel, they're opposites, and the 9x's cancel, they're opposites as well. And so this just leaves me with 3 terms, 18xh, 9h squared, and 9h. And then my last step here, well, second to last, is to take out an h. If I take out an h, it'll leave me with an 18x plus just a 9h plus a 9. And then I'll put all of this over h. And so the last thing that happens is those h's divide out, okay? And so what you're left with right here, guys, that is your difference quotient. So it appears to be choice C. All right. Number 10. Number 10 says graph this function, okay? Well, this function, you could think about transformations, guys, but it's probably just going to be easier to graph it in your calculator. It definitely cannot be C, okay? Nor do I think it can be B or D. I think it's going to be A. But I don't know why this keeps, it's kind of weird. Anyway, let me go ahead and graph it for you. So here's your square root key. You can type in there 4x and then plus 6. We'll go to graph. Whoops. Go to my standard viewing window. And there it is. So you can see that it's actually A. Just like we suspected. Now, yours will not look as steep as what we have in here, because for one thing, their viewing window is different. See, the y-axis only goes from -5 to 5, and yours goes from -10 to 10. And furthermore, guys, we talked about this. The viewing window here is actually not square. That's one reason. That's another reason. But in any case, it's A. All right, number 11. So this one says determine any relative maxima and any relative minima of the function. Well, they've got this function already graphed for us. So remember, those are peaks and valleys, okay? So right here I have a relative minimum, or excuse me, maximum. I have a relative maximum of 1. Remember, it refers to the y-coordinate, and then you list it wherever the x is. So a relative maximum of 1 whenever x is 0. And over here, I have a relative minimum of -3 whenever x is 2. So let's see which of these choices. I think it's going to be choice A. All right, number 12. So this one says, how can the graph of this square root function be obtained from this basic square root function? Well, guys, you got to start inside the square root. This plus 10 actually shifts the graph to the left 10 units. Okay? And then this negative out in front actually turns it upside down, or in other words, reflects it about the x-axis. So shift it horizontally 10 units to the left, and then reflect it across the x-axis. So it's got to be choice C. And if you're not sure, you could just go ahead and graph both of those and then compare them. All right, number 13. Find the zeros of the function. Okay, so just by looking at my answer choices, guys, I can tell that this quadratic function, its zeros are not nice numbers. And so for that, I'm going to rely on the quadratic formula. I just need to find it again. Calculator soup. Used. There it is. Okay, so look back over here. Our A is 1, our B is -7, and our C is 1. So we'll type these coefficients in. 1, -7, and 1. And this is what we come up with, okay? Now you can draw this fraction bar straight across if you want. So 7 plus or minus 3 square root of 5 all over 2. I think it's going to be D. Yeah. It's got to be D, guys. Now this one, you know, you could do by hand as well, using the quadratic formula. Okay, number 14 says, find the vertex of the parabola. Well, algebraically, you would do it by the x-coordinate of the vertex would be -b over 2a. And then your y-coordinate would come from plugging whatever that value is into the function, okay? But guys, the easiest way to do this would just be to graph it and look at your answer choices. So I think that's the way I'll do it. So x squared minus 10x and then plus 28. The graph. Okay, you know, the only thing is if like you go to graph and it's off the screen, then you could either adjust your viewing window or you could use the algebraic method. Well, it looks to me like the x-coordinate of the vertex is going to be about at 5, and the y-coordinate is probably at about 3. So because this is multiple choice, you can easily narrow it down to the answer. We always say correct answer, but that's redundant. Anyway, number 15. Find the zeros of the polynomial and then state the multiplicity of each. Okay. Alright, so this is in chapter 8. So the nice thing about this one, guys, is that it's already factored for us. So what I do is I just set my factors equal to 0. Well, you don't worry about the -5. It is a factor, but it can never equal 0. So my factors here are the x minus 6, and the x plus 2. Now to determine the multiplicities, that depends on the number of times that the factors occur. So see, here I actually have 2 factors of x. I have 1 factor of x minus 6, and I have 3 factors of x plus 2. So that tells you the multiplicities. Alright, so x equals 0, x minus 6 equals 0, and then x plus 2 equals 0. So here, you know, I'd add 6 to both sides, and I get positive 6. Over here, I'd subtract 2. Okay, so this first 0 has a multiplicity of 2 because that factor occurred twice. The second 0 has a multiplicity of 1 because that factor only occurred once. And the last 0 has a multiplicity of 3. Okay, so you just pick this out. -2 has a multiplicity of 3. 6 has a multiplicity of 1. Let's see. Oh, well, -2 a multiplicity of 3. 0 a multiplicity of 2, and then 6 a multiplicity of 1. Okay, so it's C. So be careful when you're picking these out. You could also graph this function, because remember, it'll cross the x-axis when the multiplicity is an odd number. Well, course, that doesn't really tell you what the multiplicity is. It just tells you it's an odd number. Anyway, you could still do it because you have limited choices here, so you could process of elimination. All right, number 16, graph the function. Well, guys, I just do this in my calculator, but you could look and see where the zeros are. One's going to be at 0, another one at -4, and another one at +2. So, let's see. It's got to be this one. Well, hold on a minute. No, it's actually this one. Because it touches here at -4, crosses here at 0, and touches here at +2. Okay, remember that whether it touches or crosses, that has to do with the multiplicities. The reason I know it's this one and not A is because of the negative in front. The function is turned upside down, so I know it's got to be D. So if you're not sure, guys, just graph this in your calculator. Now, in your calculator, you're only going to see a very small part of this. You're just going to see what happens at the x-axis. Because look at the y-axis, how they have the y-axis. Unless you change the range of your y, it's not going to look exactly like this. All right. Number 17, it says find the vertical asymptotes. Well, the vertical asymptotes come from what makes the denominator 0 after the function's been simplified. Okay, so if you remember back when we did this, what we did was we simplified this function by factoring both the numerator and the denominator. Well, the numerator cannot be factored, but the denominator can. Both of those terms have an x in common, so if I take out that x, that'll leave me with x plus 2. So now that I have the denominator factored, nothing cancels. Okay, but you're going to have to factor it anyway, typically to solve it. So now I'll set those factors equal to 0, and I'll get 0, and I'll get -2. That's where my two vertical asymptotes are going to be. In other words, if you graphed it, you could figure it out by graphing it too, right, guys? Just graph this function. X equals 0 and x equals -2. Okay, number 18, it says find the requested function value. So here we're doing a composition. We're going to plug -4 into G, and whatever that output is, we're going to plug that into F. Okay. All right, so we need to find G of -4. So this will become 5 times -4 squared minus 6 times -4. Oops, that should be -8. Well, let's see, I may do this in my head. That's 16 times 5 is 80, and that'll be a positive 24 minus an 8. And I think this is going to be I don't see my answer. Oh, because I'm not finished. This is going to be 96, okay? And now what I got to do is plug that into F. Okay, so F is -5 times 96 plus 4. Okay, so now, what's that going to be? I think -270 plus 4, so negative. Oh, no, I'm wrong about that. I think it's, well, let's just use the calculator. I think it's A, guys. Five times 96. Okay, that would be -480, and then plus 4 would be 476. So I knew it was close to that value. Okay. Now, number 19, this stuff should be fresher in your minds, guys. This is what we just got finished covering. So now, we're not actually finding a composition for a specific value of x. We're going to be plugging f into g. Okay? So that means we take this whole function f right here, and it goes into the x that's in g. So if I do that, I get 6 times 4x squared plus 6x plus 3, and then raised to 7. And then if I distribute that 6, I'll get 24x squared plus 36x plus 18 minus 7, and this will end up giving me, what is that, 11. Okay, so it looks like this one's going to have to be choice B. Alright, number 20, it says determine whether the given function is 1 to 1, and if it is, find its inverse. Okay, so this is from 9.2. Well, guys, this is a 1-to-1 function. You can graph it to be sure, but this will be a strictly increasing function. Okay. The only time it's not 1-to-1 is if it's like increasing, then it starts decreasing because it wouldn't pass the horizontal line test. So if it's a strictly increasing or a strictly decreasing function, it is 1-to-1. Okay. So it has an inverse, so we're going to find it. So the first step is write it as y equals 6x cubed minus 5. And then we'll swap our x and y's. And we're going to solve this for y. So I need to add 5. And equals 6y cubed equals x plus 5. And I need to divide both sides by 6. Okay. And then you got to remember the opposite of cubing something is to take the cube root of it. So I'll take the cube root of both sides, and that'll give me that my inverse function is equal to the cube root of that fraction, x plus 5 over 6. Okay. So this appears to be B. All right. I feel like this final is not too bad, especially since it's multiple choice. Okay, 21, it says match the function with one of the graphs. Well, guys, if you remember what that basic 2 to the x looks like, this one's just going to be shifted up 1 unit. So instead of crossing the y-axis at 1, it'll cross the y-axis at 2. So the only one that it could be is choice A. Because remember, a basic exponential function has a horizontal asymptote right across the x-axis. So if I shift this up 1, then the horizontal asymptote should be 1. It should be at y equals 1. Okay, so it couldn't be crossing the x-axis like they have it show right here in D. But if you're not sure, go ahead and graph it in your calculator. All right, number 22, this says convert to a logarithmic equation. Well, to convert it to a logarithmic equation, guys, you basically keep the base and you make it log base e, and then you swap the other two numbers, okay? And then that exponent goes to the other side. So log base e. Technically, the ln would be correct, but you can see they don't actually utilize the ln here in any of the choices. So it looks like the only choice this could be would be A. It's just backwards. Alright, and then let's see, 23. Oh, I hate that they gave you one like this. It's just because it's a little more work. It says express in terms of sums and differences. Okay, so first thing we need to know is that this is a square root. Basically, guys, if this is a square root, it has a little understood index of 2. And so what you can do, I'll tell you a shortcut because we did it the long way in class. The long way would be to rewrite everything under the radical with an exponent of 1/2, 1 over 2. And then you distribute that exponent 1/2. So basically you're just gonna put a 2 underneath all of these exponents. Okay, so this would become x to the 6/2, y to the 2/2 over z to the 9/2. Well, then you could simplify these. 6/2 is the same as 3, so this would become log base b of x cubed. And then 2 over 2 is 1, so just y to the first over. And then 9/2 is just going to stay 9/2. Okay? And then what you would do, guys, is you would split this apart using quotient rule. So it'll be log base b of just the numerator minus log base b of just the denominator. And then, because I have a product in this first logarithm, I can split this into 2 using the product rule. You'll end up with 2 logarithms, and they'll be separated with addition because we're utilizing the product rule. So this will be log base b of x cubed plus log base b of y minus log base b of z to the 9/2. And then the last thing would be to use the power rule, which just means you move those powers out in front. Okay, so our final answer would be 3 times log base b of x plus log base b of y minus 9/2 times log base b of z. So it looks to me to be choice C. Some of these guys it definitely couldn't be this one, because when we split them up, we split them up with either addition or subtraction. And it definitely couldn't be this one. Okay, this one here would insinuate that the only thing in the numerator was the x term. So, alright, we're almost there. This one says the number of acres in a landfill is given by this function right here. Okay, this is an exponential function where t is measured in years. So it says how many acres will the landfill have after 7 years. So what's actually happening here, guys, because this exponent is negative, the amount of land or the number of acres is decreasing. This is what happens in a landfill. So really all we're doing here is we want to plug 7 in for t. So we're just evaluating this function. You can call this function b of t and just plug in 7. Okay, so this will be, so evidently the landfill starts out with 9,100 acres and then gradually the land area is consumed with garbage. And plug a 7 in there. This one you're going to have to use your calculator for. Although it definitely could not be D or, well, it definitely could not be D. Because D would imply that the more garbage you put in it, the more acreage you end up with having available. Alright, so 9,100 I'm going to get my E from down here. I'm going to hit second and then the LN key. Then I'm going to type in my exponent, negative 0.03 times 7. I'll hit enter, and after 7 years, we're only going to have 7,376 acres left in this landfill. Okay. All right, our last one is solve this exponential equation. Okay. Well, this one, guys, you could solve by taking the log of both sides, but I'm actually going to equate the base. Equate the bases. So the base on the left-hand side is already a 2, so I can rewrite the 4 as 2 to the second power. So now that my bases are equated, then you just equate the exponents. Okay, so that means that this exponent has to equal this exponent. And then you just got a linear equation. So go ahead and solve it for x. We'll subtract 8 from both sides. We'll get this negative 6. I'll divide both sides by negative 2. We're going to get x is equal to 3. So that is the solution. This one you could do by guess and check. Well, not guess and check, but process of elimination. You can just try plugging these different values in for x and see which one turns this left-hand side into 4. Okay. All right, guys. Well, that is it. Okay. That's the review, and that's exactly what your final exam is going to look like. So, remember, too, that I will replace your lowest regular test score with whatever you make on the final, as long as the final's higher. Okay, so it's not going to penalize you if you don't do well in the final. And although this is the first time I'm recording this video, probably for a while, I'll probably reuse it for a few semesters. I want to say that I really enjoyed our class, really enjoyed getting to know all of you. And I'll miss you, okay? So I'm hoping that I'll be able to say the same in future semesters. So anyway, you guys take care, and I wish you well on that final, okay?